Hello and welcome back to this lecture series on signals and system. So now we are currently dealing with convolution, as digital convolution, and basically there are different methods of solving questions that has to do with convolutions of signals. But this particular one we are going to be looking at the tabular method. So if you are new to this lecture series on signals and system, if you missed the previous part right from the beginning, I will encourage you to kindly check the playlist on signals and system. You're going to find a link to all the videos, the previous and the future videos under the topic signals and system. And if you're also yet to subscribe, please click on that subscribe button. You'll find it at the lower right of your screen if you're on mobile, and if you're on PC, you see it somewhere just below the video. Alright, so thank you very much if you have just done that. So now in explaining convolution using tabular method, we are going to be using this example on the screen. So the example says, given the following two rectangular sequence, x of n, and this is the expression for it, and then for h of n, this is what we have for h of n. So it said convolute them using the tabular method. So one thing you also need to take note when you are trying to understand convolution is try as much as possible, especially if you are preparing for exam, try as much as possible to understand the tabular method, the graphical method. Exactly, I think there are about 4 methods. So just try as much as possible to understand them, because the question can ask you specifically to use a particular method, maybe formula method, tabular method, or graphical method. So for this now we are going to be dealing with the tabular method. So let's get started. So let's first of all establish what the diagram actually look like. So for x of n, this is the expression given. So if you are to sketch that, so let me just do a rough sketch of what it looks like. Alright, so since the end part is just 1 to 3, so we can just take it like this. So this will be 0, this is 1, this is 2, and then this is 3. So the maximum amplitude that we are having is 1. So this will be our n, and this will be our x of n. Okay, are we good? So now let's establish something. So they said when the amplitude is 1, at an amplitude of 1, n ranges from, or n is equals to 0, 1, and 2. So from 0, 1 to 2. So this is for x of n. And then for that of h of n, so it starts from 0 to 2 also. There's no negative, so we can have something like this. So 0, 1, 2, 3. This is our n. Right here we're going to have our h of n. Alright, so at 0, at an amplitude, okay, the amplitude also, the maximum amplitude here is 1. So is 1. So at an amplitude of 0, n is 0. So when n is 1 and 2, the amplitude is 1. So from 1 to 2. So this is what h of n is look like. So we are going to convolute them using the tabular method. So for us to do this, we are going to have a table that looks like this. First of all, let me write k here, or let me just use n. Now the range of values for n will just be what we have here. Exactly, and then once we flip it, okay, let me just write it here. So using h of n, by the time we flip it, the ix negative value we are going to be having is, or the least negative value rather, is minus 2. So let's pick it from minus 2, or minus 2, minus 1, 0, 1, 2, 3, 4, 5. Okay, so I hope we have enough space for this question. Right, so take note, we've done the n. Now for our x of n, which is this, so I'm just going to write it here, that our x of n, so we are going to take note of the amplitude of x of n. The amplitude here is 1 from 0 to 2. Exactly. So it could be anything depending on the question. But for this particular question, you can see that it is from 0 to 2. That's the rectangle is from 0 to 2. It's extended from 0 to 2, and the amplitude is 1. So let's take note of that. So from 0, this is 0. So we are going to be having 1, 1, 1. Exactly. So in some cases, it might be different. It might just be different numbers instead of having 1, 1, 1. But because of this nature of this question, now let's look at h of n. So one other thing we are going to do to h of n is that we are going to flip h of n. When you are dealing with convolution using the tabular method, your x of n, you really don't have any business to do with it. You don't need to touch the diagram. You don't need to flip it exactly. But for your h of n, definitely we are going to need to flip it. So let me do a rough sketch of what it will look like by the time we flip it. So by the time we flip it, or we can also say mirror, it's going to look like this. So by the time we mirror it, we are going to be having something like this. This is going to be 0, and here we're going to be having -1, -2. Okay. So this is going to be -1, -2, -3. So this, I'm going through it real quick because I've explained it earlier. So if you should flip it along the y-axis, we are going to be having something like this. Exactly. So this will be h of -n. Are we good? And then this is going to be n. Alright. So this value that we are having here, which is our h of -n, so we'll come and have it here, which is h of -n. That's the same thing we did to x of n. So for these particular values now, we are going to pick it from this -2 to, let's say, 0. And don't forget, the amplitude is still 1. So from -2, which is here, we're going to be having 1, 1, and then 0. I hope you get that. So at -2, we are having an amplitude. That's after we've reversed it, or let me just, after we've mirrored it. I'm still saying the same thing. At -2, we are having an amplitude that is 1. Don't forget, when we mirror it, the amplitude would still be the same thing. So the amplitude is 1, just like the one here. Then at -1, the amplitude is 1. At 0, there's no amplitude, that's why it is 0. Now, so what we are going to do now is we'll continue shifting the mirrored signal, that is h of n. We don't need to shift x of n. It's only h of -n that we are going to be shifting now. Exactly. So we are going to keep shifting it to the right. Are we good? So in shifting it to the right, so that means we are going to be having, here we are going to be having h of, you can have it as -n plus 1. Some material might have it as h of 1 of 1 minus n. So whichever way you want to order it. So the next one will be h of -n plus 2 and h of -n plus 3, and then where you are going to stop will determine how far you go, but I'll explain that. H of -n plus 4. So let me just stop there, and then we'll see, maybe we need to continue. Now, in the previous videos that we did, I think when we looked at this particular example, here, I explained how to shift a mirrored signal. So I won't be going too much into it in this particular one. Alright, so if you are to shift this signal now, that's +1, that means you are shifting it to the right. Exactly. So if you shift it to the right, that means you're going to be having something like this. So this will look like this. So what the difference there is that this place is going to be -1 and this is going to be 0. I hope you get that. So in shifting it once, that means the amplitude will still be the same thing, but the position will change here. Exactly. So that means at -1, the amplitude is 1. At 0, the amplitude is 1. Exactly. So at -1, the amplitude is 1. then at 0 the amplitude is 1, and then 0. So what you notice is you just keep shifting it, and then for when minus n plus 2, once you shift it also by 2, so what would happen is you are going to be having 1 1 0 here. To when it is shifted by 3, this is going to be 1 1 0, and for this it will be 1 1 0. Exactly. So let me just make some short dashes so that you don't miss the lines. Or let me use, so let me just do this. All right. So now what we want to do is, at this point, for now we are going to start from this h of minus n plus 1, or let's just pick it from h of minus n. So at this h of minus n, what we want to look out for are what we call overlap. Exactly. The overlap simply means that when we have any number that is on the same vertical line with what we have in this aqua color pen, exactly, this particular one that I circled, we are going to look at it vertically if there is any overlap on each horizontal line. Exactly. So don't worry, let's continue. I'm going to explain that very soon. All right, for this first one, h of minus n, we are going to indicate it as our y of 0. Exactly. So at this y of 0, you can see that there is only one overlap. That means this 0 is overlapping, is on the same vertical line with 1. What are we going to do? We are going to multiply it. But by the time we multiply it, it's going to give us 0. So we can just write it as 0. Exactly. So now let's go to the next line, which is this. We call this y of 1. So now let's examine this. Is there any overlap with this aqua color pen? With this one written in another color, you can see that there's an overlap, which is this one is this on the same vertical line with this. So what do? We are going to write it as, so 1 times 1, which is equals to 1. Exactly, we take note of that. So let's go to the next line, which is this. Let's call that as y of 2. So let's see if there are any overlap on the vertically with these numbers that we have here. You can see this is on the same line with this. This is on the same line with this. Let's just ignore it, because if this should multiply this, it will give us 0. So since this is on the same line, this is on the same line, so what we will do is we are going to write it as, this will multiply this. We are going to be having 1 times 1 plus 1 times 1, 1 times 1, and that will give us 2. So depending on the values, we are going to also look at another example. As you can see, this is example 1. So that will give us 2. Okay. So there is one here. All right, so let's go to the next line. So this is the next line. This is going to be y of 3. And for this now, let's look at it. Do we have any overlap? Yeah. You can see that this one is not it's not on the same vertical line with any number here. So we ignore it. But if you look here, this and this, they are on the same vertical line. If you look here and here, they are on the same vertical line. Exactly. So don't do mistake of picking this, because this is for another horizontal line itself. All right, so let's do the same thing. This is 1 times 1 plus 1 times 1. So we are going to be having it as 1 times 1 plus 1 times 1, and that will give us 2. So let's look at this. This is y of 4. For y of 4, when you look at it vertically with these 3, if you look here, there is nothing here, there is nothing here, but if you look at this to this, you can see they are on the same vertical line. So we are going to be having 1 times 1, and that will give us, and that's equals to 1. Okay. All right, so let's look at the next one. So the next one is we are going to be having is h of minus n plus 5. Okay, so for that now, so that means the values will be 1, 1, 0. Exactly, so this 0 is directly under 5. This 4, this one is like this is, and this is to this. So, alright. So let me just, so that you can get it here like this. So this is going to be y of 5. So if you notice that as y of 5 now, there is no overlap. You can see it is totally outside these three numbers that we are having here. They are not vertically aligned anymore. So at that point, this is going to be 0. And this is where we are going to stop. Exactly. So what I'm trying to say that in essence, it's not in all cases that you might need to even get to all this points. Some question you might even need to go beyond shifting it more than 5 times. Exactly. So the values we actually need now is that those are the values as let's just include the 0. That's 0, 0, 1, 2, 2, 1, and 0. So this is for y of 0, and this is for y of 1, and this is for y of 2, this is for y of 3, this is for y of 4, and then let's just take this as y of 5. So we can use this now to plot a graph of what the convolution sum will be. So you can just decide to stop here anyway, but you can just take it a step further depending on the question. So this is, if this is 0, 1, 2, 3, 4, and then 5. So this is just like a rough sketch. 4, 5, then the amplitude is 1, and then 2. That's the maximum. So if you are to sketch what we have here, so that means we are going to be having at y of 0 it is 0, at y of 1, that means this one, at 2 it is 2, then at 3 it is also 2, at 4 it is 1, then at 5 it is 0. So this is what called the convolution of these two. That's this and this. So this is what is going to give us. Exactly. So that's how to go about convolution using the tabular method. So this is example 1. In the next video, we are going to be looking at another example. This one, should I say, is more simpler and straightforward because we are using 1, 1. It's more of 1, 1, 1, especially at this point here. At this point here, we are just having 1, 1. So let's look at another examples with different values here and see what happens, how it will affect what we are having here. So I hope you find value in this. If you understand it, let me know. If you still have any doubts or any confusion, just leave them in the comment section and then I'll attend to them. So I'll see you in the next example, which is example 2 under convolution.